Okay, today we're going to start talking about section 9.2, which is the introduction to circles. A couple things we need to remember first when we're talking about circles is that the area of a circle can be found by the formula pi r squared, and the circumference formula can be found by the formula 2 pi r, or pi times the diameter. We will typically keep our answers in exact form, so we'll have pi in our answers. There will be times where we'll ask you to round the answers. A couple vocab words we're going to need to know before we continue on with the lesson is, first off, a chord is a segment that's joining 2 points that are on a circle. So we have, say, points like A and B. That segment would be a chord. And then we also have the longest chord in a circle is the diameter, because it goes from two endpoints on the circle, but it also goes through the center. So NB would also be a chord, which is also the diameter. And then there's a couple of big differences here between the measure of an arc and the length of an arc. They have a connection with each other. But the measure of the arc is the number of degrees in which it occupies in a circle. Okay? The circle has a total of 360 degrees. And then when we're finding a measure of an arc, we're finding the how much of the circle of the 360 degrees that arc is taking up. When we're talking about the length of an arc, we're talking about the actual distance on the circle. And when we're talking about the distance on the circle or the circumference, we're talking about the perimeter of the circle essentially. And when we're talking about the length, we're talking about how far around the circle that arc is going, which is why it is the length or the fraction of the circle's circumference. So we're going to find the circumference still, whatever that circumference is. And then we're going to multiply it by the fraction, that measure of the arc over 360. How much of the circle is that arc taking up? In a similar fashion, we're going to talk about the area of the sector of a circle and its relationship with the area of the whole circle. The whole circle, obviously, we could find the area doing pi r squared. But when we're talking about a sector of a circle, it's going to be having 2 radii with the arc on a circle. And this is a partial area of the circle sectioned off. So we're going to still find the area of the circle, but then multiply that area by how much, the fraction of the circle that's actually being taken up. The measure of that arc, which the arc AG, how much of the circle is being taken up. Multiply that by the whole area. And in an inscribed angle, we're talking about an angle whose vertex is on the circle and whose sides are chords. Chords, they meet with a vertex on the circle. And an inscribed angle is finding half of the measure of the arc. So angle J, let's just say, for example, that IK is 90 degrees. And the measure of angle J would equal 90 divided by 2, which is 45 degrees. So how do we incorporate that into some examples? The first example, find the circumference in the area of the circle. So we need to remember our formulas. And in this case, we are given the radius, so we're just going to plug in the radius into our formulas. So the circumference is 2 pi times the radius of 3.4, which gives us a circumference of 6.8 pi. And the area, if we plug in the radius of 3.4, we're going to square 3.4, then multiply that by pi, and we'll get an area of 11.56 pi. Now these two answers are both in exact form. We can also multiply the pi to get a decimal form. Number 2, it tells us that the circle's diameter is 8, which means we could also use that the radius is 4. And it tells us that the arc that we are using is using up 3/4 of the circle. Now that allows us to find the measure, because remember the measure is in degrees. We want to find the degree that that arc is taking up. If it's taking up 3/4 of the circle, we need to remember that the circle takes up 360 degrees, and we're only taking up 3/4 of it with that arc. So we need to find out what 3/4 of 360 is, and know that the measure of arc AB is 270 degrees. With the length, we still want to know the fraction of the circle, so it's still taking up 3/4 of the circle. But remember, the length, we're talking about the distance, and we're talking about the fraction of the circle's circumference. So the fraction is the 3/4 part. And then we need to find the circumference of the circle, and if it has a radius of 4, then we know that the circumference is 8 pi. So the length is 3/4 of 8 pi, which is 6 pi. And last, we're talking about the area of that sector, and again, it's 3/4 of the circle that is going to be shaded in. And this time we're taking the fraction of the area, which is pi r squared. So we can plug in the radius of 4. So in this case we're taking 3/4 of 16 pi, which would give us 12 pi. Go ahead and pause the video and do numbers 3 and 4, and then we will check the answers. The first thing we need to know in number 3 in order to find the area is that the radius, the distance from the center to the point on the circle, goes from the origin to 8, 0, which gives us a radius of 8. So now we can use that to find the area of the sector. We have 3/4 of the circle that is shaded here, so we need to find 3/4 of the circle's area. And with a radius of 8, we know that the area is 64 pi, so 3/4 of 64 pi gives us 48 pi. We're talking about an inscribed angle. We're talking about an angle here that is half of its corresponding arc here, the intercepted arc. So we're going to take 80 degrees and divide it by 2, which gives us 40 degrees. For number 5, in order to find the coordinates of the center of the circle, because we are given the endpoints of the diameter, we know that the center of the circle must be the midpoint of those endpoints, so we're finding the midpoint of the endpoints of the diameter. So we can go ahead and use the midpoint formula. We're going to add up our x's and divide by 2, and add up our y's and divide by 2, and get a center value of -2, 1. In number 6, we're going to show that triangle INS is a right triangle by 2 ways. First off, we can see that the angle that's asking us to find INS is an inscribed angle because its vertex is on the circle, and it is intercepting the diameter. So the diameter means that we have half of the circle above and half of the circle below. And with half of the circle below, we know that this arc down here is 180 degrees, and that is the arc that this angle is intercepting. So an inscribed angle is the arc divided by 2, so 180 degrees divided by 2 gives us a 90-degree angle, which tells us that this is a right triangle. We could also show up by finding the slopes of those two lines by plugging them into our slope formula and verifying that in order for it to be a right angle, then we need perpendicular lines, which means we need slopes are opposites and reciprocals. So go ahead and plug in IN and NS to find the slopes. And when you plug in the slopes, you get 1/2 and -2, which tells you that yes, they are perpendicular, since it is a right angle. Go ahead and finish number 7 for tomorrow. We will check that in class, and that concludes section 9.2.